AI isn't just getting faster, it's getting heavier. Every new model demands more compute, more storage, and more power than the one before it. And today, we've reached a point where the world's data centers, the backbone of the entire internet, are no longer able to keep up. The buildings that run your apps, your banks, your hospitals, your governments, and even your AI tools are quietly reaching their breaking point. And the biggest tech companies in the world are now scrambling to redesign everything from the ground up. This isn't an upgrade, this is a survival move. Because the truth is simple. AI has outgrown the world's infrastructure, and if we don't reinvent data centers now, the system that supports our digital lives could collapse under its own weight. For the past decade, data centers followed a predictable playbook: shrink the chips, stack more servers, cool the room, and lower operating costs. It worked until generative AI arrived. A single large model today demands 10 to 50 times more computing power than the heaviest workloads companies used just 5 years ago. In 2025, Microsoft, Google, Meta, Amazon, and nvidia all quietly admitted the same thing. Their existing data centers cannot handle the next generation of AI models. They can't support them physically, thermally, or electrically. Some projections say the world will need 40 gigawatts of new data center power capacity by 2030. That's equivalent to building the entire output of 40 nuclear power plants, just to run AI. And the painful reality is that we don't have that kind of infrastructure ready. The biggest bottleneck isn't servers or chips, it's electricity. AI-heavy data centers now consume 5 times more power than traditional cloud facilities. A single hyperscale AI center can use as much electricity as a full-sized city. And with Blackwell-class and Rubin-class GPUs coming, the demand is only rising. Cities like Phoenix, Dublin, and Singapore have already paused new data center approvals because their power grids can't handle the load. In many regions, AI demand is growing faster than power companies can build new transmission lines. This has forced tech giants to rethink everything. For the first time in history, data centers must become energy producers, not just energy consumers. To escape grid limitations, companies are pursuing energy strategies once used only in scientific labs and military bases. Microsoft and OpenAI are exploring small, modular nuclear reactors to produce reliable, carbon-free baseload power directly on-site. Others are building massive solar farms and battery systems next to their data centers, though solar alone cannot support 24/7 AI workloads without equally massive storage. Some facilities are adding their own liquid natural gas turbines to produce consistent energy when renewable output isn't enough. AI isn't just changing how we design data centers, it's rewriting the global energy map. But the next crisis is just as severe: heat. Traditional air cooling, the giant fan systems used in standard data centers, is now obsolete. When GPU clusters run at full load for weeks, air can't cool them fast enough. If companies don't change their cooling systems entirely, their clusters literally overheat and shut down. That's why the industry has shifted to liquid cooling, pumping chilled liquid directly across the chips, similar to how high-performance engines are cooled. The most extreme setups use immersion cooling, where entire racks are submerged in special non-conductive liquids that remove heat 10 times more efficiently than air. Large data centers now rely on massive water loop systems, circulating millions of gallons of water each day. Some AI facilities require up to 5 million gallons of water per day, more than some towns use. This has created growing controversy as communities demand transparency about where large tech companies get their water and how they return it. Because of power, water, and land constraints, the data centers of the future are being built in entirely new locations. Companies are moving to colder regions like Norway, Finland, Canada, and Iceland to reduce cooling costs naturally. Many new campuses are rising near massive water bodies such as the Columbia River or Lake Michigan to support cooling systems. Others are being built directly beside power plants to avoid relying on aging electrical grids. Some experiments even place data centers underground or underwater. Microsoft's underwater project revealed that submerged servers fail far less often because they face fewer temperature fluctuations. This means the data centers of the future may not even be built on land. Even inside the walls, everything is changing. Traditional data centers were designed for CPU-based computing, but AI flips the architecture entirely. The new model is GPU first. That means ultra-dense racks filled with thousands of accelerators tightly packed to maximize compute per square meter. These racks require extremely high bandwidth connections because large AI models don't run on one GPU, they run on thousands, acting as a single organism. Cooling systems now operate at the chip level, not the room level. And the buildings themselves are modular, designed like Lego blocks, so companies can expand rapidly without rebuilding entire facilities. This GPU-first architecture didn't exist 5 years ago, and now it's the new global standard. The facilities themselves are evolving into megastructures. The next generation of AI infrastructure won't be single buildings, they'll be entire campuses the size of airports. Microsoft's Wisconsin expansion, Amazon's Virginia superclusters, Meta's Nebraska campus. These aren't data centers, they're AI megacities. Each campus includes private substations, dedicated fiber routes, industrial-scale water treatment plants, energy storage sites, emergency, cooling reservoirs, and multi-million-gallon thermal tanks. These are no longer server rooms. They are national infrastructure. And this redesign is happening for one reason. AI is scaling at a rate the world has never seen. Models are doubling in size every 7 to 10 months, demanding exponentially more compute. But data centers were built for a world where computing grew 10% a year. The mismatch has created a crisis. Our AI ambitions have grown far faster than the buildings designed to support them. So now the race is on. Whoever builds the fastest, most efficient, AI-optimized data centers will lead the next decade. Microsoft, Google, AWS, Meta, and nvidia are no longer just competing on models. They're competing on infrastructure. Because the future of AI won't be decided in corporate boardrooms. It will be decided inside the walls of the world's next-generation data centers. AI has forced a revolution nobody predicted, not in software, but in concrete, steel, energy, and water. The companies that adapt will lead the AI era. The ones that don't will collapse under their own compute demand. Because ultimately, the future of AI won't be shaped by the smartest algorithms, but by the data centers powerful enough to train them.